Why, hello there. It is me, Villa Lactea, or also Vía Láctea, como el nombre de nuestra galaxia, like the name of our galaxy. I'm a big fan of the great unknown above us. I just think space is really cool. So, tonight I thought I'd be your tour guide through the solar system and geek out a bit. In other words, I'll be reading from the Wikipedia page for the solar system. But I'll be giving my sort of opinion, review of the solar system, of each planet and stuff, and just what I think about it. So yeah, just sit back, relax, use your mind's eye to imagine going through at more than light speed through each of the planets and objects of the solar system with me. So, I'll just be starting at the section labeled Inner Solar System. The Inner Solar System is a region comprising of the terrestrial planets and the asteroid belt. Composed mainly of silicates and metals, the objects of the Inner Solar System are relatively close to the Sun. The radius of this entire region is less than the distance between the orbits of Jupiter and Saturn. This region is also within the frost line, which is a little less than 5 astronomical units, 750 million kilometers, 460 million miles from the Sun. Inner planets. The 4 terrestrial or inner planets have dense, rocky compositions, few or no moons at all, and no ring systems. They are composed largely of refractory minerals such as the silicates, which form their crusts and mantles, and metals such as iron and nickel, which form their cores. 3 of the 4 inner planets, Venus, Earth, and Mars, have atmospheres substantial enough to generate weather. All have impact craters and tectonic surface features such as rift valleys and volcanoes. The term inner planet should not be confused with inferior planet, which designates those planets that are closer to the Sun than Earth, in other words, Mercury and Venus. Mercury. Mercury is the closest planet to the Sun, being anywhere between 28.5 and 54.7 million miles. Being the smallest planet of the solar system, Mercury has no natural satellites. The dominant geological features are impact craters or basins with ejecta blankets, the remains of early volcanic activity, including magma flows in lobed ridges or roops that were probably produced by a period of contraction early in the planet's history. Mercury's very tenuous atmosphere consists of solar wind particles trapped by Mercury's magnetic field, as well as atoms blasted off its surface by the solar wind. Its relatively large iron core and thin mantle have not yet been adequately explained. Hypotheses include that its outer layers were stripped off by a giant impact, or that it was prevented from fully accreting by the young sun's energy. There have been searches for volcanoids, asteroids in stable orbits between Mercury and the Sun, but none have been discovered. So Mercury, in my opinion, is sort of just like a glorified asteroid. It's very small compared to the rest of the planets, and it's very gray Just has a lot of craters on it. Maybe it's more of a glorified moon. That's it. And I love when something of Mercury, when it's called Mercurian. I love that. What's it called? Denonym? Something like that. No. Something like that. The adjective used when it's like of something, you know. I really like Mercurian, but I really love Venusian or Venus. Venus being anywhere from 66.7 to 67.7 million miles from the sun, is close in size to Earth, being only 0.815 masses of the Earth, and, like Earth, has a thick silicate mantle around an iron core and a substantial atmosphere, and evidence of internal geological activity. It is much drier than Earth, and its atmosphere is 90 times as dense. Venus has no natural satellites. It is the hottest planet, with surface temperatures over 400 degrees Celsius, or 752 degrees Fahrenheit, mainly due to the amount of greenhouse gases in the atmosphere. The planet has no magnetic field that would prevent depletion of its substantial atmosphere, which suggests that its atmosphere is being replenished by volcanic eruptions. A relatively young planetary surface displays extensive evidence of volcanic activity, but is devoid of plate tectonics like here on Earth. It may undergo resurfacing episodes on a timescale of 700 million years. So I think, like a lot of people, Venus is sort of associated with beauty, you know, the Venus being the Roman god of beauty. And it does look very soft and gentle on the outside, but if you've ever seen pictures of it inside, it looks more hellish than Mars. But I still think it's a cool planet, and it comprises, or it is, the morning star or evening star that appears as one of the brightest objects in the sky, which is called Lucero de la Tarde, or Lucero del Alba in Spanish, is where the name Lucifer comes from. Apparently. Interesting. Now for everybody's favorite planet, Earth. Earth, being 91.4 to 94.5 million miles from the sun, is the largest and densest of the inner planets, the only one known to have current geological activity, and the only place in the universe where life is known to exist. Its liquid hydrosphere is unique among the terrestrial planets because it is the only planet where plate tectonics have been observed. Earth's atmosphere is radically different from those of the other planets, having been altered by the presence of life to contain 21% free oxygen. The planetary magnetosphere shields the surface from solar and cosmic radiation, limiting atmospheric stripping and maintaining habitability. It has one natural satellite, the Moon, the only large satellite of the terrestrial planets in the solar system. So yeah, who doesn't love Earth, right? It's where I was born. It's blue, which apparently is a lot of people's favorite color, blue. It has water, which I drink often, although not as often as I should. Mars. Mars, being 128.5 to 154.9 million miles from the sun, is smaller than Earth and Venus, being 0.107 masses of the Earth. It has an atmosphere of mostly carbon dioxide with a surface pressure of 6.1 millibars, roughly 0.6 that of Earth, but sufficient to support weather phenomena. Its surface, peppered with volcanoes such as Olympus Mons, and rift valleys such as the Valles Marineris, shows geological activity that may have persisted until as recent as 2 million years ago. Wow, that's very recent. Its red color comes from the iron oxide or rust in its soil. Mars has 2 tiny natural satellites, Deimos and Phobos, thought to be either captured asteroids or ejected debris from a massive impact early in Mars's history. I think it's really cool that, we have things that we made, we put on another planet. I think it's easy to sort of underappreciate that, since we got people on the moon, like humans on the moon. But I don't know. I think it's really cool that's possible. That's a thing humans did. And apparently it could have life. Like it's a thing that every so often it's like, oh, new discovery for life on Mars, as if that hasn't been said before. But Mars is a sort of the guinea pig, I guess, of the solar system, if you don't count Earth for humans. Asteroid belts. Asteroids, except for the largest, Ceres, named after my favorite VTuber, Ceres Fauna, are classified as small solar system bodies and are composed of mainly refractory, rocky, metallic minerals with some ice. They range from a few meters to hundreds of kilometers in size. Asteroids smaller than 1 meter are usually called meteoroids, and micrometeoroids, grain-sized, with the exact division between the two categories being debated over the years. As of 2017, the International Astronomical Union, the IAU, designates asteroids having diameter between 30 micrometers and 1 meter as micrometeoroids. In terms smaller particles, dust. I'm glad we got that sorted out. The asteroid belt occupies the orbit between Mars and Jupiter, between 2.3 and 3.3 astronomical units from the Sun. It is thought to be remnants of the solar system's formation that failed to coalesce because of the gravitational interference of Jupiter. The asteroid contains tens of thousands, maybe possibly millions, of objects over 1 kilometer in diameter. Despite this, the total mass of the asteroid belt is unlikely to be more than 1,000th that of Earth. The asteroid belt is very sparsely populated. Spacecraft routinely pass through without incident. Ceres. Ceres, being 257 million miles from the Sun, is the largest asteroid, a protoplanet even, and a dwarf planet. It has a diameter of slightly under 1,000 kilometers, and a mass large enough for its own gravity to pull it into a spherical shape. Ceres was considered a planet when it was discovered in 1801, but as further observations revealed additional asteroids, it became common to consider it as one of the minor rather than major planets. It was then reclassified again as a dwarf planet in 2006, when the IAU definition of a planet was established. Pallas and Vesta. Pallas and Vesta are the largest asteroids in the asteroid belt after Ceres. They are the only 2 protoplanets that survive more or less intact. At about 520 kilometers in diameter, they were large enough to have developed planetary geology in the past, but both have suffered large impacts and have been battered out of being round. Fragments from impacts upon these two bodies survive elsewhere in the asteroid belt, as the Pallas family and the Vesta family. Both were considered planets upon their discoveries in 1802 and 1807 respectively, but then, like Ceres, generally considered a minor planet with the discovery of more asteroids. Some authors today have begun to consider Pallas and Vesta as planets again, along with Ceres, under geophysical definitions of the term. I don't know, in my opinion, I feel like there should be a distinction between things in the asteroid belt and things not in an asteroid belt. I think the fact that we can see a lot of the planets with the naked eye kind of says something about them, even though we can't see like Uranus and Neptune from Earth with just our eyes, even though they're planets. But I don't know. Asteroid groups. Asteroids in the asteroid belt are divided into asteroid groups and families based on their orbital characteristics. Kirkwood gaps are sharp dips in the distribution of asteroid orbits that correspond to orbital resonances with Jupiter. Asteroid moons are asteroids that orbit larger asteroids. They are not as clearly distinguished as planetary moons, sometimes being almost as large as their partners. The asteroid belt includes main belt comets, which may have been the source of Earth's water. Jupiter Trojans are located in either Jupiter's L4 or L5 points, being the gravitationally stable regions leading and trailing a planet in its orbit. The term Trojan is also used for small bodies and any other planetary or satellite Lagrange point. Hilda asteroids are in a 2 to 3 resonance with Jupiter. That is, they go around the Sun 3 times for every 2 Jupiter orbits. Interesting. The inner solar system contains near-Earth asteroids, many of which cross the orbits of the inner planets. Some of them may be potentially hazardous objects. I'm glad you enjoyed the inner solar system. Now we'll be moving on to the outer solar system. Very, very far away. The outer region of the solar system is home to the giant planets and their large moons. The Centaurs and many short-period comets also orbit this region. Due to their greater distance from the Sun, the solid objects of the outer solar system contain a higher proportion of volatiles, such as water, ammonia, and methane, than those of the inner solar system, because the lower temperatures allow these compounds to remain solid. Outer planets. The 4 outer planets, also called giant planets or Jovian planets, collectively make up 99% of the mass known to orbit the Sun. That's kind of ominous. Known to orbit the Sun. Jupiter and Saturn are together more than 400 times the mass of the Earth and consist overwhelmingly of the gases hydrogen and helium, hence their designation as gas giants. Uranus and Neptune are far less massive, less than 20 Earth masses each, and composed primarily of ices. For these reasons, some astronomers suggest they belong in their own category, the ice giants. All 4 giant planets have rings, although only Saturn's ring system is easily observed from Earth. The term superior planet designates planets outside of Earth's orbit and thus includes both the outer planets and Mars. The ring moon systems of Jupiter, Saturn, and Uranus are like miniature versions of the solar system. That of Neptune is significantly different, having been disrupted by the capture of its largest moon, Triton. Jupiter, being 460.2 to 500.7 million miles from the Sun. At 318 masses of the Earth, it is 2 times the mass of all other planets put together. It is composed largely of hydrogen and helium. Jupiter's strong internal heat creates semi-permanent features in its atmosphere, such as cloud bands and the Great Red Spot. The planet possesses 4.2 to 14 Gauss-strength magnetosphere that spans 22 to 29 million kilometers, making it, in certain respects, the largest object in the solar system. Jupiter has 95 known satellites, aka moons. The 4 largest, Ganymede, Callisto, Io, and Europa, are called the Galilean moons. They show similarities to the terrestrial planets, such as volcanism and internal heating. Ganymede, the largest satellite in the solar system, is larger than Mercury. Callisto is almost as large. Yeah, Jupiter's just badass, isn't it? Like very aptly named as king of the gods, king of the planets, Jupiter, which in Latin is apparently a shortening of Deus Pater, or Father God. So yeah, what a big boy. Saturn, being 843 to 936.1 million miles from the Sun, distinguished by its extensive ring system, has several similarities to Jupiter, such as its atmospheric composition and magnetosphere. Although Saturn has 60% of Jupiter's volume, it is less than a third as massive, at 95 masses of the Earth. Saturn is the only planet in the solar system that is less dense than water. The rings of Saturn are made of small ice and rock particles. Saturn has 145 confirmed satellites composed largely of ice. 2 of these, Titan and Enceladus, show signs of geological activity. They, as well as 5 other Saturnian moons, Iapetus, Rhea, Dione, Tethys, and Mimas, are large enough to be round. Titan, the second largest moon in the solar system, is bigger than Mercury and the only satellite in the solar system to have a substantial atmosphere. Yeah, Saturn's the cool parent. You know, if Jupiter is like the sort of like the responsible one, because apparently its gravity kind of deviates a lot of asteroids from hitting Earth because of its gravity. It's the like big and responsible parent, and Saturn's the cool planet, the cool parent. It has the looks and the swagger, and I don't know. I mean, not that Jupiter doesn't have the looks, but you know. Anyway, Uranus. Yes, I pronounce it Uranus. I will not pronounce it any other way. Uranus. Okay, fine. Uranus is 1.698 to 1.865 billion miles. Not millions anymore. We're at billions of miles from the Sun. At 14 Earth masses. It has the lowest mass of the outer planets. Uniquely among the planets, it orbits the Sun on its side. Its axial tilt is over 90 degrees to the ecliptic. This gives the planet extreme seasonal variation, as each pole points towards and then away from the Sun. It has a much colder core than the other giant planets and radiates very little heat into space. As a consequence, it has the coldest planetary atmosphere in the solar system. Uranus has 27 known satellites, the largest ones being Titania, Oberon, Umbriel, Ariel, and Miranda. Like the other giant planets, it possesses a ring system and magnetosphere. Yeah, I always pronounced it Uranus. That's how I learned in my quantum pad learning system. And, yeah, it's the funny one. No, actually, but I think it's kind of cool that it kind of orbits on its side. Kind of like a, I don't know, a Beyblade, but instead of spinning on its, like, tip, it spins on the sort of, like, equator of it, on the edges. I don't know. Neptune being 2.778 to 2.832 billion miles from the sun. Though slightly smaller than Uranus, is more massive than Uranus, at 17 masses of the Earth, and hence more dense. It radiates more internal heat than Uranus, but not as much as Jupiter or Saturn. Neptune has 14 known satellites. The largest, Triton, is geologically active with geysers of liquid nitrogen. Triton is the only large satellite with a retrograde orbit, which indicates that it did not form with Neptune, but was probably captured from the Kuiper Belt. Neptune is accompanied in its orbit by several minor planets, termed Neptune Trojans, that either lead or trail the planet by about 1/6 of the way around the Sun, positions known as Lagrange points. Centaurs. The Centaurs are icy comet-like bodies whose orbits have semi-major axes greater than of Jupiter and less than Neptune's. These are former Kuiper Belt and scattered disk objects that were gravitationally perturbed closer to the Sun by the other planets, and are expected to become comets or get ejected out of the solar system. While most centaurs are inactive and asteroid-like, some exhibit clear cometary activity, such as the first centaur discovered, 2060 Chiron, which has been classified as a comet because it develops a coma just as comets do when they approach the Sun. The largest known centaur, 10199 Chiriclo, these are catchy names by the way, has a diameter of about 250 kilometers and is one of the only few minor planets known to possess a ring system. I didn't know about these. I assume they're centaurs in the sense that maybe they're half comet, half planet, like dwarf planet, maybe, possibly. Comets. Comets are small solar system bodies, typically only a few kilometers across, composed largely of volatile ices. They have highly eccentric orbits, generally a perihelion within the orbits of the inner planets, and an aphelion far beyond Pluto. I think perihelion is the point in the orbit where it is closest to the Sun. It crosses the orbits of other planets, but then when it orbits away, it goes all the way beyond Pluto, but then goes really close to the Sun. So it's like a very oval shape, a very kind of like a skew. When a comet enters the inner solar system, its proximity to the Sun causes its icy surface to sublimate and ionize, creating a coma a long tail of gas and dust, often visible to the naked eye. Short-period comets have orbits lasting less than 200 years. Long-period comets have orbits lasting thousands of years. Short-period comets are thought to originate in the Kuiper Belt, whereas long-period comets, such as Hale-Bopp, are thought to originate in the Oort cloud. Many comet groups, such as the Kreutz Sungrazers, what a cool band name, formed from the breakup of a single parent. Some comets with hyperbolic orbits may originate outside the solar system, but determining their precise orbits is difficult. Old comets, whose volatiles have mostly been driven out by solar warming, are often categorized as asteroids. The trans-neptunian region. Inside the orbit of Neptune is the planetary region of the solar system. Beyond the orbit of Neptune lies the area of the trans-neptunian region, with the donut-shaped Kuiper Belt, home of Pluto and several other dwarf planets, and an overlapping disk of shattered objects, which is tilted towards the plane of the solar system and reaches much further out than the Kuiper Belt. Their entire region is still largely unexplored. It appears to consist overwhelmingly of many thousands of small worlds, the largest having a diameter only a fifth of that of Earth, and a mass far smaller than that of the Moon, composed mainly of rock and ice. This region is sometimes described as the third zone of the solar system, enclosing the inner and outer solar system. The Kuiper Belt. The Kuiper Belt is a great ring of debris, similar to the asteroid belt, but consisting mainly of objects composed primarily of ice. It extends between 30 and 50 astronomical units, or 2.8 to 4.6 billion miles from the Sun. It is composed mainly of small solar system bodies, although the largest few were probably large enough to be dwarf planets. There are estimated to be over 100,000 Kuiper Belt objects with a diameter greater than 50 kilometers. But the total mass of the Kuiper Belt is thought to be only a tenth or even 100th the mass of the Earth. Many Kuiper Belt objects have satellites, and most have orbits that take them outside the plane of the ecliptic. I think the plane of the ecliptic is just where all the planets kind of, the sort of imaginary flat disk where all the planets kind of gravitate. So anything that goes kind of like above or below that sort of plane, that's outside the ecliptic. The ecliptic also, sorry, this is just tangent. The ecliptic is also in the sky, from our perspective, where all the zodiac constellations are. Because that's the route the sun takes. Because we're on the ecliptic. So, anyway, the Kuiper Belt can be roughly divided into the classical belt and the resonant trans-neptunian objects. I think I belong in the latter group. The latter have orbits whose periods are in a simple ratio to that of Neptune. For example, going around the Sun twice for every 3 times that Neptune does, or once for every 2. The classical belt consists of objects having no resonance with Neptune, and extends from roughly 39.4 to 47.7 astronomical units, or 3.66 to 4.43 billion miles. Members of the classical Kuiper Belt are sometimes called cubanos, after the first of their kind to be discovered. Members of the classical Kuiper Belt are sometimes called cubiwanos, after the first of their kind to be discovered, originally designated as 1992 QB1. They are still in their primordial, low eccentricity orbits. Pluto and Charon. It's pronounced Charon, not Karen. The dwarf planet Pluto, with an average orbit of 39 astronomical units or 3.6 billion miles from the Sun, is the largest known object in the Kuiper Belt. When discovered in 1930, it was considered to be the 9th planet. This changed in 2006 with the adoption of the formal definition of planet. Pluto has a relatively eccentric orbit inclined at 17 degrees to the ecliptic plane and ranging from 29.7 astronomical units or 2.76 billion miles from the Sun at perihelion, which is within the orbit of Neptune, to 49.5 astronomical units or 4.6 billion miles at aphelion. Pluto has 2 to 3 resonance with Neptune, meaning that Pluto orbits twice around the Sun for every 3 Neptunian orbits. Kuiper Belt objects whose orbits share this resonance are called Plutinos. Charon, the largest of Pluto's moons, is sometimes described as part of a binary system with Pluto, as the two bodies orbit a barycenter of gravity above their surfaces. They appear to orbit each other. Beyond Charon, 4 much smaller moons, Styx, Nix, Kerberos, and Hydra, orbit Pluto. This is news to me. They sound like names of like a punk band members. I guess it is STYX, Styx. Nix is NIX. Kerberos with a K. And Hydra. Besides Pluto, astronomers generally agree that there are at least 4 other Kuiper Belt objects that are dwarf planets, and additional bodies have also been proposed. There's Makemake, although smaller than Pluto, is the largest known of the classical Kuiper Belt. That is a Kuiper Belt object not confirmed with resonance with Neptune. Makemake is the brightest object in the Kuiper Belt after Pluto. Discovered in 2005, it was officially named in 2009. Its orbit is far more inclined than of Pluto's at 29 degrees. It has 1 known moon. Haumea is in an orbit similar to Makemake, except that it has a temporary 7 to 12 orbital resonance with Neptune. Like Makemake, it was discovered in 2005. Uniquely among the dwarf planets, Haumea possesses a ring system, 2 known moons named Hi'iaka and Namaka, and rotates so quickly, once every 3.9 hours, that it is stretched into an ellipsoid. It is part of the collisional family of the Kuiper Belt objects that share similar orbits, which suggests a giant collision took place in Haumea and ejected its fragments into space billions of years ago. Quaoar, it's Quaoar. Quaoar is the second largest known object in the classical Kuiper Belt, after Makemake. Its orbit is significantly less eccentric and inclined than those of Makemake and Haumea. It possesses a ring system and 1 known moon, Weiwot. And Orcus is in the same 2 to 3 orbital resonance with Neptune as Pluto, and is the largest such object after Pluto itself. Its eccentricity and inclination are similar to Pluto's, but its perihelion lies about 120 degrees from that of Pluto. Thus, the phase of Orcus's orbit is opposite to Pluto's. Orcus is at aphelion, around when Pluto is at perihelion, and vice versa. For this reason, it has been called the anti-Pluto. It has 1 known moon, Vanth. Okay, I believe we're gonna skip ahead a little bit to the final section, the edge of the heliosphere. the farthest regions. The point at which the solar system ends and the interstellar space begins is not precisely defined because its outer boundaries are shaped by two forces: the solar wind and the sun's gravity. The limit of the solar system's wind's influence is roughly 4 times Pluto's distance from the sun. This heliopause, the outer boundary of the heliosphere, is considered the beginning of the interstellar medium. The sun's Hill sphere, the effective range of its gravitational dominance, is thought to extend up to 1,000 times farther and encompasses the hypothetical Oort cloud. Oh, I did not know it was only hypothetical. That's interesting. The edge of the heliosphere, the sun's stellar wind bubble, the heliosphere, a region of space dominated by the sun, has its boundary at the termination shock, which is roughly 80 to 100 astronomical units from the sun upwind of the interstellar medium to roughly 200 astronomical units from the sun downwind. So basically think of it as like an egg, but the yolk is very, very skewed to one side of the egg. So there's like a upwind is where the yolk is closer to the shell, and downwind is where it's the rest of the egg, the empty white part of the egg. That's how you can think of that. Here, the solar wind collides with the interstellar medium and dramatically slows, condenses, and becomes more turbulent, forming a great oval structure known as the heliosheath. This structure has been theorized to look and behave very much like a comet's tail, extending outward for a further 40 astronomical units on the upwind side, but tailing many times the distance downwind. Evidence from the Cassini and Interstellar Boundary Explorer spacecraft has suggested that it is forced into a bubble shape by the constraining action of the interstellar magnetic field, but the actual shape remains unknown. The outer boundary of the heliosphere, the heliopause, is the point at which the solar wind finally terminates and is the beginning of interstellar space. Voyager 1 and Voyager 2 passed the termination shock and entered the heliosheath at 94 and 84 astronomical units from the sun, respectively. Voyager 1 was reported to have crossed the heliopause in August 2012, and Voyager 2 in December of 2018. The shape and form of the outer edge of the heliosphere is likely affected by fluid dynamics of interaction with the interstellar medium, as well as solar magnetic fields prevailing to the south. In other words, it is bluntly shaped, with the northern hemisphere extending 9 astronomical units farther than the southern hemisphere. North and south relative to what? The ecliptic? I think so. Beyond the heliopause, at around 230 AU, lies the bow shock, a plasma wake left by the sun as it travels through the Milky Way. Detached objects. Sedna, with an average orbit of 570 AU from the sun, is a large reddish object with a gigantic, highly elliptical orbit that takes it from about 76 astronomical units at perihelion to 940 astronomical units at aphelion, and takes 11,400 years to complete. Mike Brown, who discovered the object in 2003, asserts that it cannot be part of the scattered disk or the Kuiper belt because its perihelion is too distant to have been affected by Neptune's migration. He and other astronomers consider it to be the first of an entirely new population, sometimes termed distant detached objects, or DDOs. which also may include the object 200 CR105, very catchy name, which has a perihelion of 45 astronomical units, an aphelion of 415 astronomical units, and an orbital period of 3,420 years. Brown terms this population the inner Oort cloud because it may have formed through a similar process, although it is far closer to the Sun. Sedna is very likely a dwarf planet, though its shape has yet to be determined. The second unequivocally detached object, with a perihelion farther than Sedna's at roughly 81 AU, is 2012 VP 113. Discovered in 2012. Its aphelion is only about half of that of Sedna's, being 458 astronomical units. If you couldn't tell, we're in the sort of deep end of the iceberg of solar system stuff. The Oort cloud, or Oort cloud? That's two O's, but the Oort cloud is a hypothetical spherical cloud of up to 1 trillion icy objects, and is thought to be the source for all long-period comets to surround the solar system at roughly 50,000 astronomical units, or around 1 light year. Yes, we're barely at 1 light year from the Sun, and possibly as far as 100,000 astronomical units, or 1.87 light years. It is thought to be composed of comets that were ejected from the inner solar system by gravitational interactions with the outer planets. Oort cloud objects move very slowly and can be perturbed by infrequent events, such as collisions, the gravitational effects of a passing star, or the galactic tide, the tidal force exerted by the Milky Way. Boundaries. Very important. Much of the solar system is still unknown. The Sun's gravitational field is estimated to dominate the gravitational forces of surrounding stars out to about 2 light years. Lower estimates of the radius for the Oort cloud, by contrast, do not place it further than 50,000 astronomical units. Most of the mass is orbiting in the region between 3,000 and 100,000 astronomical units. Despite discoveries such as Sedna, the region between the Kuiper Belt and the Oort cloud, an area tens of thousands of astronomical Despite such discoveries as Sedna, the region between the Kuiper Belt and the Oort cloud, an area tens of thousands of astronomical units in radius, is virtually unmapped. Learning about this region of space is difficult because it depends upon references from those few objects whose orbits happen to be perturbed such that they fall closer to the Sun, and even then, detecting these objects have been possible only when they happen to become bright enough to register as comets. Objects may yet be discovered in the solar system's uncharted regions. The farthest known objects, such as the comet West, have aphelia around 70,000 astronomical units from the Sun. Well, it seems we have reached the extent of the solar system. There is still more to this page that I am quite tempted to read, actually. But maybe many of you have fallen asleep. But for those who are still here listening to my voice, even after all this time and all these miles away from anything known to humans, thank you very much. Maybe next time I'll read about the Milky Way itself. How very apt. I hope that you've enjoyed this journey across the solar system as much as I have. I've learned a lot of things, and I hope you have too. Until next time, I hope your dreams reach further than the Oort cloud.